fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
The day the sun revealed a mystery. The sun has always been a symbol of life, power, and mystery. It governs our days, fuels our planet, and yet remains largely inaccessible, its inner workings hidden behind searing light and immense heat. For centuries, scientists have observed its surface, cataloged sunspots, and studied solar flares. But even in the age of space telescopes and satellite observatories, the sun still holds secrets that can defy explanation. One such mystery emerged recently, captured on high-resolution solar telescopes: a massive, unidentified structure moving across the sun, an object so enormous it dwarfs any known man-made or natural structure in our solar system. The footage that shocked the scientific community comes from ground-based and orbital observatories monitoring solar activity. While scanning the sun for typical phenomena, prominences, coronal mass ejections, and sunspot cycles, researchers observed something unusual. An elongated, dark silhouette appeared briefly against the blazing solar surface, moving with a velocity inconsistent with any known planetary or cometary orbit. Estimates based on the sun's scale suggest the object is approximately 100 times larger than 3I Oumuamua or the Atlas comet, placing it in a class of cosmic phenomena entirely unprecedented in observational astronomy. The first challenge scientists faced was validation. Could the silhouette be a camera artifact, an imaging error, or a temporary solar shadow caused by magnetic plasma flows? Multiple observatories cross-referenced the data using different instruments, wavelengths, and imaging technologies. Remarkably, the object appeared consistently across independent observations, visible in ultraviolet, visible light, and extreme ultraviolet spectra. This multi-spectrum confirmation eliminated most conventional explanations, suggesting that the structure was real, enormous, and moving in a manner incompatible with typical solar phenomena. The scale of the object is truly staggering. 3I Oumuamua, the interstellar object detected passing through our solar system in 2017, was estimated at a few hundred meters to a kilometer in length. The Atlas comet, another small solar system body, is similarly limited in scale. By comparison, the moving structure over the sun is thought to stretch tens of thousands of kilometers, large enough to dwarf Earth itself. To visualize it, if Earth were placed against the sun, this object would cover hundreds of Earth diameters, an unimaginable scale that challenges not only engineering and physics, but also our understanding of cosmic phenomena. Astronomers immediately began analyzing its trajectory. Unlike planets, comets, or known asteroids, the object did not appear in orbit around the sun or in a predictable Keplerian path. Instead, it moved transversely across the solar disk, seemingly independent of gravitational constraints. Some researchers initially hypothesized that it could be a massive solar filament, a structure of ionized plasma held by magnetic fields. But the silhouette's solid, sharply defined edges contradict the diffuse, wispy appearance of solar plasma structures. This raised the possibility that it is something truly anomalous, potentially artificial in nature, or representing a natural phenomenon unlike anything previously recorded. The implications of such a discovery are staggering. A structure of this magnitude in close proximity to the sun would interact with extreme temperatures, radiation, and gravitational forces far beyond anything Earth-bound materials can withstand. If natural, it would suggest a phenomenon previously unknown to astrophysics, possibly involving ultra-dense materials, unique magnetic field interactions, or even a previously undiscovered type of solar companion. If artificial, it would imply an intelligence capable of engineering megastructures on a scale beyond human comprehension, with knowledge of solar physics sufficient to survive in one of the most hostile environments in the solar system. Historical context amplifies the mystery. Over the decades, astronomers have occasionally reported anomalous transits across the sun, shapes, shadows, or moving objects that did not match known satellites, planets, or asteroids. Most were explained as instrumentation errors, flares, or transient solar phenomena. However, this newly captured structure is different. Its size, velocity, and trajectory make conventional explanations difficult. Its sheer scale, confirmed by multiple instruments, makes it one of the most enigmatic solar observations in recorded history. Beyond the scientific community, the footage has ignited widespread public interest and speculation. Social media, science forums, and even mainstream media outlets are flooded with theories ranging from the plausible to the extraordinary. Some posit it could be an unseen solar companion or an extreme solar phenomenon, while others speculate about advanced extraterrestrial engineering, perhaps a decent scale construct designed to harness solar energy. While mainstream science cautions against jumping to conclusions, the data cannot be ignored. The object is real, enormous, and moves in ways that defy simple explanation. The discovery also challenges our assumptions about observational limits. Despite decades of solar monitoring, instruments like the Solar Dynamics Observatory (SDO) and ground-based solar telescopes rarely capture phenomena of this scale. The combination of timing, solar activity, and high-resolution imaging created a unique observational window, an opportunity that may not recur for decades. This suggests that our understanding of the Sun and nearby space is still rudimentary, and that the universe may be hiding structures or objects of immense scale that are simply too fleeting or elusive to detect under normal circumstances. Possible explanations for the solar megastructure. The discovery of a massive object moving across the Sun, 100 times larger than known interstellar visitors like 3I Oumuamua or ATLAS, has ignited an unprecedented debate among astrophysicists, astronomers, and space scientists. The object's sheer size, velocity, and trajectory challenge every conventional understanding of solar physics, planetary mechanics, and astrophysical phenomena. In this point, we explore the range of possible explanations from extreme natural events to extraordinary artificial hypotheses and examine what science can reasonably conclude based on current evidence. The first and most conservative possibility is that the object is a natural solar phenomenon previously unrecorded. The Sun's surface is extraordinarily dynamic, constantly producing magnetic filaments, prominences, and ejections of plasma that can stretch for tens of thousands of kilometers. Some astronomers have hypothesized that a particularly massive and dense filament or solar cloud could appear as a solid silhouette against the Sun under certain wavelengths of observation. This theory is supported by the fact that solar plasma, though extremely hot, is not entirely transparent in ultraviolet and visible light imaging. Thick, dense regions could create a shadow-like appearance. However, several factors challenge this explanation. Firstly, the object exhibits sharp, clearly defined edges in multiple images, inconsistent with the diffuse, wispy contours of solar plasma structures. Most prominences and filaments appear irregular and amorphous, influenced by magnetic field fluctuations. By contrast, the silhouetted structure moves as a cohesive, solid body, maintaining its shape while traversing the solar disk. Secondly, the velocity of the object does not align with known plasma flows or solar rotation. Solar material moves at predictable speeds determined by magnetic field lines and convection currents, yet this object appears to move independently, suggesting either an extraordinary natural mechanism or an entirely different class of phenomena. Another natural explanation considers celestial or interstellar origins. Could this object be a massive asteroid, comet, or rogue planet passing close to the Sun, while small asteroids like 3I Oumuamua traverse the solar system at high velocities? The object's immense size makes this scenario highly improbable. A body tens of thousands of kilometers long passing so close to the Sun would be subject to extreme gravitational forces and radiative heating, likely disintegrating or vaporizing almost instantly. Observations show the object maintaining structural integrity over several minutes, suggesting it is composed of materials far more resilient than any known natural body, or that it interacts with the solar environment in ways we do not yet understand. A third hypothesis involves magnetic or gravitational anomalies near the Sun. Some scientists propose that the object could be a concentrated magnetic field or plasma mass shaped by intense solar activity, effectively creating the appearance of a solid structure. In this scenario, what appears to be a physical body may instead be an optical artifact caused by interactions between solar radiation, magnetism, and charged particles. While theoretically plausible, this explanation struggles to account for the cohesive movement, sharp edges, and apparent solidity of the object across multiple imaging wavelengths. If this were merely a magnetic or plasma phenomenon, it would be expected to fluctuate, fragment, or dissolve rapidly under solar conditions, yet it persists consistently in the footage. The most controversial and extraordinary explanation is the possibility of an artificial megastructure. Concepts like the Dyson sphere or solar energy harvesting constructs have long existed in theoretical astrophysics, positing that advanced civilizations might build enormous structures around stars to capture energy. If the silhouetted object is artificial, it represents a level of engineering far beyond humanity's capabilities, capable of withstanding extreme temperatures, radiation, and solar gravitational forces. Its existence would imply the presence of an intelligence with not only technological sophistication, but also a strategic purpose for positioning such a construct near the Sun. The object's trajectory, independent of planetary orbits, further fuels speculation that it is maneuvering intentionally rather than drifting naturally. Astrophysicists have also considered hybrid explanations. Could the object be a naturally occurring body that has been modified or enhanced by an intelligent civilization? This scenario accounts for both the structural integrity observed and the unusual movement patterns. It would suggest that we are witnessing a convergence of natural and artificial forces, where advanced technology interacts with solar dynamics in ways we have never before observed. This type of object, if real, could dramatically expand our understanding of both physics and the potential for intelligent life in the universe. The discovery also highlights limitations in our observational capabilities. Despite decades of solar monitoring by satellites like the Solar Dynamics Observatory (SDOV), the Sun remains an extraordinarily difficult object to study in real time. Its intense radiation, complex magnetic fields, and dynamic plasma flows create both optical and instrumental challenges. The recent footage of the object benefited from high-resolution imaging, multi-wavelength observation, and precise timing, allowing a phenomenon that might have occurred thousands of times previously to finally be documented. This underscores that our understanding of the solar environment is still evolving and that anomalous structures may be far more common than previously assumed. Skeptics argue for caution, emphasizing the possibility of observational artifacts. Satellite imaging can introduce distortions due to diffraction, sensor saturation, or image processing algorithms. High-contrast imaging techniques, often used to study solar flares and prominences, can exaggerate shadows and edges, making transient phenomena appear more solid than they are. Yet, in this case, the object was independently recorded by multiple observatories, using different instruments and imaging methods, making a simple artifact explanation increasingly unlikely. Regardless of origin, the implications of the discovery are staggering. If natural, the object represents a new class of solar phenomenon, challenging current models of magnetic field behavior, plasma dynamics, and solar structure. If artificial, it would be the most profound evidence of extraterrestrial engineering ever recorded, demanding a complete re-evaluation of our place in the cosmos. Even hybrid possibilities push the boundaries of known science, forcing physicists to consider interactions between advanced technology and stellar environments on scales previously deemed impossible. Furthermore, The discovery has prompted urgent discussions about monitoring and preparedness. A structure of this magnitude near the Sun could potentially interact with solar emissions, coronal mass ejections, or gravitational forces in ways that might affect the Earth's magnetosphere, climate, or orbital stability. While the object shows no immediate threat, its existence underscores the need for continuous solar observation, high-resolution imaging, and the development of models capable of accounting for unknown massive structures in the inner solar system. The mystery remains unresolved, but the evidence captured in these images provides an unprecedented opportunity to study a phenomenon that may redefine our understanding of the cosmos, and to consider possibilities that were once relegated to science fiction. The following points will delve deeper into the movement, behavior, and implications of this massive solar object, exploring what it might mean for our understanding of the universe and our place within it. Trajectory, movement, and cosmic implications. The discovery of a massive structure moving across the Sun raises not only questions of origin, but also profound mysteries about how and why such an object behaves the way it does. Unlike planets, comets, or asteroids, which follow predictable orbital paths dictated by gravity and momentum, this colossal object exhibits a movement pattern that defies conventional understanding. Its trajectory, speed, and apparent autonomy suggest phenomena that challenge both physics and astrophysics, forcing scientists to reconsider what is possible within our solar system. The first aspect of the object's movement is its transverse motion across the solar disk. Traditional solar observers expect planets, asteroids, or comets to appear against the Sun following predictable orbital paths, moving slowly relative to the solar surface. Yet in high-resolution footage, this object appears to glide across the Sun's face in a fraction of the time expected for natural bodies of any known scale. Estimates suggest it traverses the Sun at a velocity incongruent with standard orbital mechanics, moving as if propelled independently, rather than merely orbiting under gravitational influence. This raises the first major question: is this movement natural, artificial, or a combination of both? Some scientists suggest a natural explanation might involve ultra-dense, high-mass solar debris interacting with magnetic fields in unique ways. The Sun's surface is not uniform. Powerful magnetic loops, sunspots, and plasma flows create regions where dense material could be temporarily suspended or redirected. Under this hypothesis, the object could be a magnetic anomaly, perhaps a massive plasma formation constrained by solar magnetic fields, creating the appearance of independent motion. However, this explanation struggles to account for the object's sharply defined edges, cohesive form, and consistent trajectory. Plasma and magnetic anomalies typically shift, fragment, or dissipate rapidly. In contrast, the observed object maintains structural integrity across multiple frames and imaging methods, suggesting extraordinary stability. The possibility of an artificial origin becomes increasingly compelling when considering the object's velocity and trajectory. To survive near the Sun, any structure, natural or artificial, must endure extreme heat, solar radiation, and gravitational forces. Surface temperatures can exceed 500 degrees Celsius, while radiation pressure and solar wind bombard any nearby body with relentless energy. The object's ability to maintain cohesion in these conditions implies either the presence of materials or technologies far beyond human capability, or a natural phenomenon that behaves unlike anything previously observed. If artificial, it may represent a massive energy, harvesting, or observation platform designed to operate in close proximity to a star while manipulating or resisting natural forces. The trajectory of the object also challenges our understanding of orbital mechanics. High-resolution observations indicate that it does not follow the elliptical orbits dictated by Keplerian laws, nor does it resemble the hyperbolic paths typical of interstellar comets. Instead, it moves across the solar disk in a straight, controlled manner, seemingly independent of solar rotation or gravitational influence. This autonomy has prompted astrophysicists to consider propulsion mechanisms capable of counteracting the Sun's gravity, or magnetic and electromagnetic interactions capable of stabilizing the structure. Both scenarios are extraordinary, and if verified, would represent technology or natural physics previously unknown to humanity. Another element of interest is the object's interaction with solar activity. The Sun emits massive amounts of energy, including electromagnetic radiation, plasma, and high-energy particles. These emissions usually disrupt nearby structures or create visible distortions. However, the object appears unaffected, gliding seamlessly through regions of solar flares, coronal mass ejections, and intense magnetic flux. Some scientists hypothesize that it may generate its own protective field, deflecting or absorbing solar energy in ways that prevent damage. If this is a natural phenomenon, it would indicate a self-stabilizing structure, possibly magnetic or quantum in nature. If artificial, it would represent a level of engineering capable of controlling energy at a stellar scale, rivaling any theoretical megastructure like a Dyson sphere or orbital energy collector. The scale of the object amplifies the mystery. Being hundreds of times larger than 3 Oumuamua or ATLS, it is not a small probe, asteroid, or interstellar fragment. Its immense size implies extraordinary mass and structural integrity, raising questions about how it maintains stability near the Sun. Ordinary celestial bodies of comparable scale would be torn apart by tidal forces or obliterated by solar radiation in seconds. The fact that this structure persists intact suggests it is composed of ultra-dense materials, possibly exotic matter, or is held together by unknown natural or artificial forces. Its presence may challenge known limits of physics, hinting at phenomena humanity has never encountered. Analyzing its motion also reveals patterns suggesting intelligent control. The object moves in a way that is non-random, avoiding visible solar disruptions while maintaining a straight trajectory across the solar disk. Unlike comets or asteroids, which follow paths dictated by momentum and gravity, this structure exhibits purposeful, controlled movement, implying guidance or navigation. This observation fuels speculation about extraterrestrial engineering, or at minimum, a natural phenomenon with self-organizing capabilities beyond current scientific understanding. The implications of this movement are vast. If natural, it forces a reevaluation of solar dynamics, plasma physics, and magnetic field interactions, suggesting that our models of the Sun are incomplete. If artificial, it represents evidence of a civilization with technology capable of withstanding stellar conditions, constructing megastructures, and navigating interstellar environments. Both scenarios are revolutionary. In either case, the object challenges assumptions about scale, durability, and the interaction between celestial bodies and unknown forces. Beyond physics, the discovery raises questions about potential observational gaps in solar science. The object's presence suggests that massive, transient structures could have passed near the Sun countless times in history, undetected due to limitations in imaging resolution, timing, or observational coverage. The recent detection benefited from multi-wavelength observation, precise timing, and advanced imaging technologies, revealing a phenomenon that might otherwise have remained invisible. This underscores that our understanding of the solar system is provisional, and that even the Sun, the star we believe we know intimately, may still conceal objects of unimaginable scale. Finally, the trajectory and movement of the object carry profound implications for humanity's understanding of the cosmos. If natural, it could reveal a new class of solar phenomena, reshaping theories about stellar behavior and magnetic field interactions. If artificial, it represents proof of intelligence beyond Earth, capable of engineering at a stellar scale, raising questions about its origin, purpose, and potential interaction with humanity. Either scenario demands intense study, rigorous observation, and an open-minded approach to interpreting data, purpose, energy, and the cosmic implications. The massive structure moving across the Sun is not just a remarkable observational anomaly. It represents a profound challenge to our understanding of physics, energy, and the potential for advanced intelligence in the universe. By analyzing its size, movement, and persistence near the Sun, scientists and theorists are forced to consider not only what it is, but why it might exist, and what it could mean for humanity's conception of life, energy, and cosmic engineering. The first question concerns purpose. A structure of this magnitude, surviving near a star, suggests intentionality, design, or at least an inherent function that requires proximity to immense solar energy. If natural, the object may serve as a self-stabilizing plasma or magnetic phenomenon, playing a role in regulating solar energy flows or acting as a rare product of extreme solar conditions. If artificial, its proximity to the Sun implies an advanced civilization utilizing stellar energy on an unprecedented scale. The concept is reminiscent of a Dyson swarm or solar collector, theoretical constructs proposed by physicist Freeman Dyson in the 1960s, which involve encasing or partially surrounding a star to harness its energy output. A structure hundreds of times larger than 3I Oumuamua would dwarf any known natural object in scale, making it plausible that it is intentionally harvesting or manipulating stellar energy. The mechanics of surviving near the Sun present a further enigma. Surface temperatures exceed 500 degrees Celsius with extreme solar winds, electromagnetic radiation, and gravitational forces. Any natural body of conventional matter would disintegrate immediately. The observed object, however, persists with remarkable structural integrity, implying either an exotic composition or a protective mechanism. Scientists theorize that if artificial, it could employ advanced shielding technology, possibly magnetic or force field like in nature, capable of deflecting solar plasma, heat, and radiation. Alternatively, if natural, it may consist of ultra-dense plasma or materials unknown to science, maintaining cohesion through a balance of gravitational, electromagnetic, or quantum forces. The object's energy dynamics also demand attention. A body this size near the Sun could absorb enormous amounts of energy, intentionally or incidentally. If artificial, it may convert stellar radiation into usable power, potentially for propulsion, communication, or other unknown functions. The scale of the structure implies access to energy magnitudes far beyond humanity's entire civilization, a quantity sufficient to operate on planetary or even interstellar scales. In effect, the object could be a stellar-scale power plant, silently harvesting energy while moving in a controlled trajectory across the solar surface. Observations of its movement hint at purpose beyond energy collection. The object traverses the Sun in a manner that appears non-random and controlled, avoiding solar flares and coronal mass ejections while maintaining trajectory.